Good morning, good afternoon, good evening, depending upon where you are today. Today's webinar is focusing on cutting the cost and improving the software quality with SpiraTeam. This is part of the Journey Into Agile With Inflectra series. My name is Dr. Sriram Rajgopalan. I have my PhD degree in Organization and Management, focusing on leadership, my Master's in Business Administration, Master's in Computer Engineering, Bachelor in Electronics and Communication Engineering. I started my career as a software engineer, moved along as team leader, business analyst, project manager, scrum master, agile coach, and I have also served in the capacities of director and vice president. I have a number of different certifications, which include portfolio management, program management, project management, risk management, agile, scrum, and I'm also an instructional designer, speaker, and author. I have experiences teaching in a number of colleges in the US, India, and Vietnam. Today's webinar is part of the 5-part series on Journey into Agile with Inflectra. Each webinar is 1 hour long. We will reserve time at the end for questions. The webinars introduce the concept using a tool. There is some expectation, therefore, on your part to set up access with SpiraTeam. The completion certificate is based on specific requirements and passing a certification quiz. The process for Agile by Inflectra certificate course is as follows. You register for the webinar and attend it. If you can't attend it, view the archive when it becomes available. Experiment with SpiraTeam, take and pass the quiz. Do that for all the 5 webinars and you will be eligible to receive the certificate. There is a FAQ document we have prepared in this particular link shown, and you may want to look into that for additional questions. So today's focus is going to be cutting the cost and improving the quality. When people look at the webinar title, I am sure many focus on cutting costs. Everyone's focus today is reducing the overall cost associated with project management and reducing the total cost of ownership with product development and product management. One of my professional contacts, who has been a tester for almost 20 years, was looking for a job and mentioned to me that the market currently looks for testers with skills in automation and analysis of data and trends. So things have changed. Earlier in the webinars, I had this phenomenon of management always looking for doing more, better, cheaper, and faster with fewer resources. Just like how some incorrectly conclude that Agile solves all problems, some incorrectly believe automation solves all problems with quality. Applying the principles of Stephen Covey in his book on First Things First, I want to start with the end in mind. So let's understand quality first and how to plan for quality from the beginning. The concepts of quality have been taught for several decades. There are numerous quality gurus that have advanced simplistic frameworks that have stood the test of time and are applicable even today. One of the first definitions of quality came from conformance to requirements. The construct was advanced by Phil Crosby in 1979. Almost 2 to 3 decades before, Joseph Giron emphasized the quality of any product or service is a function of how well it is fit for use. One has to always remember that without a structured process on how to produce a product or service, quality can't be guaranteed. Even Agile, that advances the notion of individuals and interactions over processes and tools, came up with guidelines on estimation, practices for games, list of 4 specific ceremonies with suggested time limits, and somewhat prescriptive questions to maintain the progress with the daily stand-up. This concept of process guidance, so that we don't always focus the energy on too much upfront planning, was prompted by Edward Deming with his Plan, Do, Check, Act PDCA cycle. Deming's PDCA, sometimes also called Plan, Do, Study, Act PDSA, goes back to late 1950s. As a result, the concepts of iterative and incremental cycles existed in the middle of last century, which laid the foundation to the progressive elaboration that the Project Management Institute PMI adapted since its first iteration of Project Management Book of Knowledge PMBOK. A few years later, Karo Ishikawa, who is most well known for the root cause analysis diagram also known as fishbone or Ishikawa diagram, suggested the notion that management should form a committee of cross-functional team members who should have the responsibility for promoting new ideas, for building quality. As you can see, the concepts of quality is not an afterthought, but a planned event with cross-functional representation focusing on both product quality and process quality, evaluated in small increments iteratively, has been sowed as the fine seeds to build great product goes back to several decades. So, how does ISO 9000 define managing quality? The total amount of activities of the general management function which determine the policy in the field of quality in order to implement the objectives and the responsibilities in the quality system by specific means such as quality planning, quality control, quality assurance, and quality improvement. Therefore, the quality management framework aims at achieving organizational objectives through continuous improvement, customer satisfaction, and innovation. So the quality of any output and outcome delivered by a project is not just focused on testing. On the contrary, project quality is all about the application and evaluation of protocols, policies, and procedures to ensure validation and verification of project deliverables meeting the project requirements. Now that we have established the why and what behind some of the quality management framework, how should we manage quality? First, we should encourage a systems approach to value creation. In the last webinar, we discussed the systems thinking, evaluating the customer value add, business value add, technical value add, and process value add. Such a holistic approach to value creation is critical in product development, product management, product marketing, project management, and program management. Then, the project scope or the state of the backlog should represent the customer's voice of quality. Starting from the needs assessment to the solution evaluation, the quality should represent both the conformance to requirements as well as the continued fitness for use. This would mean there is a traceability from the commercial business requirements to the technical design specifications. So when the boundary conditions around the design are challenged, the system should be robust enough to handle or graciously shut down. Such a focus will not come from one group alone and can only come from a cross-functional team. Unless the project, product, and the organizational business environment are conducive for people to actively engage without the fear of failure, cross-functional knowledge sharing will not be realized. As people try experiments or spikes, as Agile calls it, developing prototypes or proof of concepts, there should be a focus on both continuous improvement and operational excellence. In the 4 important ceremonies for delivering Agile projects better, we discussed the need for review and retrospective sessions where the focus is both on the product and the process. Last but not the least, quality should be proactive, and so quality management should advance innovative approaches on continuously doing more, better, cheaper, and faster. Our internal benchmarks should be constantly evaluated so that we become operationally better, raising our own standard of quality excellence. When we do this, we can reach the quality guru's dreams of quality being free, resulting in 0 defects. But is this happening? If the reason for poor quality is because of the linear waterfall thinking associated with plan-driven approaches to software development, then how much has Agile really solved poor software quality? Going back to the annual State of Agile survey published in 2018 by version 1, adapting Agile has only claimed 46% increased software quality while allowing accelerated software delivery among changing priorities. Working within the Agile teams, productivity is still not greater and alignment between business and IT is not at its highest. Nevertheless, we should credit Agile for putting the spotlight on engineering practices required to build quality by design. The concept of technical debt maintenance and refactoring, for instance, have been part of Agile approaches to the software development for some time. One of the Agile approaches, extreme programming, even emphasized that the continuous attention to technical excellence and good design will allow the team to respond to changes rapidly. However, even the State of Agile survey didn't report on this pattern until recently in the last 2 years. So when we look at the engineering practices that contribute to good software development, these practices are unit testing, coding standards, continuous integration, refactoring, continuous deployment, pair programming, test-driven development, automated acceptance testing, collective code ownership, sustainable pace, behavior-driven development, and emergent design. If you see the trends between 2017 and 2018 in this graph, you can see some patterns evolve. Ignoring the trends where there is almost a flat pattern within plus or minus 2% tolerance, you can see that our focus seems to be continuously integrating code frequently and also take time to refactor the code. Now, refactoring is an approach to make the code more maintainable and therefore does not necessarily have a pronounced effect on functionality or performance. Then the shift comes towards test-driven development where the code is written to pass the test. I would like you to recall my reference to testable in the curtain approach to requirements definition in the previous webinar. Sustainable pace is more towards time boxing approach applied even in engineering design solutions. While these are good, you can see some challenges too that don't contribute to the quality and hence increase the cost. For instance, the trend in unit testing is reducing. Automation is not always necessarily the solution for unit testing. Additionally, we seem to decrease using recommended best practices in coding standards. These are the standards around naming conventions for variables and classes and functions, proper formatting of the code for better readability, use of proper logical exception handling, and developing unit test cases to support test-driven development. I recall reading a book on writing clean code by Robert Martin that was not only for technical people like software engineer or system analyst, but also for business professionals like project manager and team leader. I personally relate to the need for knowing the best practices even in the coding guidelines because the Agile principles emphasize not only self-organizing team responsible for coming up with the best architecture, requirement, and design, but also revolve around the fact that business people and technical people collaborate daily. This best practice then forms the common language for people to work with. Moreover, another trend you can see is that although continuous integration is increasing, the continuous deployment is not. Now, this could be because of the technical challenges in implementing the continuous integration and continuous deployment, often called the CI/CD pipeline, across the development, test, and production environment, or the continued preference for some tools that lack the visibility to all these areas in a single application lifecycle management tool. Whatever be the reason, if we don't continuously deploy binary to a production-like environment, then the opportunities for integration and regression testing of all the modules is not realized. We don't detect defects early enough, and so the cost of the defect increases. This is where automation truly helps, and if we increase automation testing but not increase the continuous deployment, the threat of defects continues to thrive. Finally, if we reduce and eliminate testers because we have automated testing, the opportunities for the testers to act as another pairs of eyes is also eliminated. So as you can see, accommodating change and accelerating time to market has taken over the need for quality. When customers reject the product, requiring rework or extending the project duration or requiring additional iterations to fix the defects, cost of product development increases. Then how are we promoting quality by design if we fail to accommodate all the engineering best practices? So the more we allow a defect, the more we allow the costs increase. This thought leads us to think about how much does a defect cost. It is needless to say that the earlier we detect the defect, the lesser we pay. For instance, if we detected an incorrect or ambiguous requirement, it is easier to correct it as either the use case or user story is getting developed for modification. If we have implemented a prototype and the analysis or design is wrong, then we have increased the cost of our misunderstanding that allowed the defect. So as the defect goes through the software lifecycle, the impact of the defect in the customer hand is exponentially high. We will now have many things like requirements, test cases, design and development and deployment corrected. Not to mention the customer dissatisfaction or the loss of trust. About 5 years back, I published an article in a peer-reviewed international journal of software engineering on the myths of software development on what we now call waterfall. Royce, credited with the SDLC, often misinterpreted to be a linear waterfall, identified progressive stages on requirements transformed through analysis, supported by design, developed and inspected for quality, and transitioned into operations for continuous maintenance. As he built his case in this paper for developing software, he proposed an interim structure that will not work. That's the diagram where more practitioners stopped at failing to read further. In fact, he cited reasons why this linear flow will not work, as customers are distant in this process. So he didn't recommend waterfall or linear thinking. On the contrary, he suggested a continuous feedback between each stage, promoting proactive inspection even before the code was developed. The concepts of progressive elaboration he advocated had incremental and iterated thinking always built in. In fact, he didn't stop at the feedback to the preceding stage. He even recommended a double feedback loop, creating a compelling case for why one should look at design if testing failed to look further beyond the development. Similarly, if the design is not stable or scalable, he suggested going back to the requirements validation. These thoughts made it into the V model of software development that involved both verification and validation. So as you can see, practitioners created a non-existing theory of software development lifecycle, failing to uphold quality at the forefront. So quality is not built into the product or project at the testing stage. It's a planned event right from the needs assessment in the requirements gathering stage. So a good quality management plan must incorporate quality by design in every software development stage and should cultivate a continuous improvement mindset to evaluate all the things that contribute or fail to contribute to quality. This means the quality management plan should look at three elements to address both conformance to requirements and fitness for use. These are the process quality, project quality, and product quality. I am not providing these three elements with any priority. All are equally important. Let's explore them in detail. A project, by definition, is a temporary activity to produce a unique product, service, or result. Whether you build a tangible or intangible product, there is also additional service elements that one has to incorporate in the project. We discussed the need for services being the first element of the stage approach to maintaining an application lifecycle management in the first webinar. So, I would like to present a few dimensions of both the product quality and service quality. Not all these elements may apply to all products or services that you may be responsible for, but knowing them helps in what you are probably missing out as you build your product or start your project. None of these dimensions are also mutually exclusive and are therefore interrelated. The dimensions of product quality. First, let's start with performance. This is the efficiency with which a product achieves its intended purpose. Remember, efficiency is about doing things right. So engaging the right stakeholder and building appropriate best practices and processes that allow the product to meet the customer's need is part of performance. Features. The dimension of a product's minimum characteristics expected for continued use. If you recall earlier webinars, we discussed how the minimally marketable features MMF contribute to the minimum viable product MVP. Reliability. This is the propensity for a product to perform consistently over its useful design life. Many electronic products these days seem to have a lower shelf life. My analog watch is over 30 years old but still works compared to my iPhone that needs replacement every 2 years. Conformance. This is the compliance to the extent a product is within the allowable range of deviation. This is when you use the Six Sigma foundations like the upper and lower control limits, establishing the region of tolerance. Several types of control charts exist which are beyond the scope of our discussion. Durability. This is the extent to which a product tolerates stress. Now, this aspect can be tested with stress, penetration, and volume testing to check for the break-even point. Ideally, we are looking for when performance can deteriorate and can be attributed to the product's failure. Serviceability, the ease with which a product's deficiency can be located for repair. Look at the dashboard in your car, supported by software with several error codes allowing the service technician to get extensive details. Aesthetics, elements or parameters that people associate as branding. For example, what makes an iMovie or Final Cut Pro used by creative designers and animation artists so different that they have to associate only with Apple products instead of going to Microsoft or Linux world of products? Perceived quality. The perceived quality is the voice of the customer. Constant innovation, delivering more than what is asked, unique differentiators. Basically, I feel like the product is pivotal for my personal or professional life. That perception is what we are referring as perceived quality. Now, let's look at the service quality. The first is the tangibles. This is the appearance that makes me feel welcome. In the software world, this could also mean a user manual, a system manual, an FAQ, context-sensitive help, etc. Service reliability. This refers to the dependable performance. Whether you include a chat service, an email response, or a callback phone service, the ability to maintain the service level agreements makes the customer come back to you. Responsiveness. Responsiveness extends service reliability. For instance, you may not have an answer for the customer within the time frame committed, or the response may not be the appropriate one to tell the customer, especially when the customer has waited for a long time. Therefore, doing additional research to get a better response or a validated response while informing that you are working on the details is important. Assurance. This is the demonstration of knowledge to extend the dependable service. This is where you demonstrate customers' unsaid needs. For instance, designing a marketing campaign based on analysis of data telling which medium or channel they may interact more. Finally, empathy. This is the demonstration of care. A follow-up service to check on whether the problem has been solved or not is an example of empathy. While the product owners, business analysts, or project managers' skills, competencies, and capabilities are instrumental in identifying these requirements, everyone in the software development lifecycle should be engaged to contribute. The organizational culture and team culture should maintain just enough processes, making it impossible to allow quality compromises. From the Japanese contributions to the lean world, 3 elements contribute to quality compromises. The first is Muda. This represents the inconsistent, uneven, or unnecessary demands on processes and people. When spikes in demand for people's time or processes exist that do not contribute to the value add, it takes productivity away. Remember my earlier discussion on non-value add. The second is Muri, where we overburden people, process, and systems. Examples are not giving enough training required for automation, but require people to automate and evaluate their performance. Both Muda and Muri contribute to Mura, which generates 8 types of waste. Lean uses an acronym called downtime to describe these 8 wastes. These are defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and excess processing. It is true that some of these elements are associated in a manufacturing context, but some of these wastes also contribute to software development. In the interest of time, let me pick defects and non-utilized talent. Either due to missing the requirement because of not doing needs assessment properly, or due to a misinterpretation of the requirement, if we produced a defect, it leads to time and money wasted in addressing the defect. If we fail to delegate the right responsibility or seek expertise available for any reason, then we are not tapping into the available talent. These in turn contribute to defects, waiting, or excess processing. I call these as management debt, where people compromise quality for the speed to market. Say, if any one of the above factors contributed to a schedule slip of 10% on a project that cost $100,000, at a minimum, $10,000 lost. That is 10% of $100,000. That is now an additional cost to the project that could have been effectively controlled. This leads us to the notion of cost of quality. It refers to the total cost of all the efforts related to quality through the product lifecycle. Now, what we often see is only the iceberg above the water. These above the surface issues manifest as defects, scrap work, time spent with inspection, etc. But what's scarce is the size of the iceberg under the water. Time spent with maintaining operations, coming up with workarounds to address design and product deficiencies, time lost in the fire drills for production issues or field failures, the use of tools beyond their shelf life because of personal preferences, and rushing work without giving enough time to do a quality job. All these costs of quality challenges manifest either as cost of conformance or cost of non-conformance. Within the cost of conformance, we can either take the time to build quality proactively, preventing costs that we will later incur if the quality is compromised. This involves training people with the tools of the trade, giving time for them to get trained, and coming up with process documentation such as coding standards, requirements traceability, use of application lifecycle management tool, and building reasonable time in the schedule to do it right. That is what quality assurance is: proactive and process-based checks and balances. When the scope is variable and the schedule is fixed within the agile iterations, then if we build quality by design, then defects should not exist. Well, we all know to err is human. Most managers, analysts, architects, developers, and testers are still human. This is where the quality control comes in, with reactive and product-based testing focused on inspection. But if we had inspected the design and requirements as part of our SDLC, incorporating feedback loops suggested, the number and types of defects would be far fewer. When we don't conform to building and assessing quality, the cost of non-conformance is a failure. This failure may be detected internally within the organization, such as project or agile team. The failure costs associated with rework the solution addressing the defect takes time and resources. Sometimes this may involve developing the work that is often scrap, that is needed to check, but not needed for the solution deployed. This is when the contingency reserves are getting depleted, requiring us to go to management reserves. When the failure is actually detected by the customer, it is called escaped defect and is an external failure. Many different types of costs come into play, which may deplete management reserves and require much more to compensate for lost business, extended warranty and recalls, and legal costs, leading to many types of liabilities. I want to quickly illustrate the nature of the costs involved. The way we normally budget the cost as part of our projects, regardless of the framework, is we avoid prevention costs as optional. When the defects arise as part of the work, these costs mount up. When failures come up, these exponentially start increasing. This is linear thinking. Instead, we should be spending more on the prevention cost because the ROI on the prevention cost is we avoid defects, internal failure, and external failure. Now, automation does not address the process-based proactive preventive costs. It helps, however, with the appraisal and internal failure. But when the external failures arise in the form of liabilities and warranties, automation does not help. About 10 years back, Forrester Research published an article with 7 steps to improving software quality. These are still relevant today, and I have added my own thoughts as well here. First, define quality to meet business needs. This could involve delivering value and achieving stakeholder satisfaction. Then, use simple quality metrics. Basically, understand the impact of quality and ensure that everyone has some kind of a scorecard goal to contribute to quality. Next, include quality in individual and team goals. First of all, incorporate quality by design. This reduces the defects, which we illustrated in the cost of a defect. Get the requirements right. This avoids unnecessary rework and also articulates corrections early. Then, test smarter to test less. Prioritize and test critical features. Understand the difference between priority and severity. Include business user acceptance testing as part of software quality. Design application to lessen the bugs and the risks associated with the bugs. Map business requirements to technical specification. Incrementally also test the architecture and the design. Finally, optimize the use of testing tools. Automate mundane tasks for reliability and repeatability. Explore tools that give transparency to software development lifecycle. But where is quality? Let's take a look at this diagram that people are often used to defining software development lifecycle. When you look at how the customer explained it, how the project leader understood it, how the engineer designed it, how the programmer wrote it, how the sales executive described it, how the project was documented, what operations installed, how the customer was billed, how the help desk supported it, and what the customer really needed, where is quality? Quality should be in all aspects so that you are constantly building this. We would never be with this so much gap if only we had incorporated quality by design. This leads us to what we call as house of quality. This is a graphical illustration linking requirements and specification traceability. This facilitates prioritization of work. This is used when we want to understand customer needs and expectation much more than they can articulate themselves. It promotes the strength in terms of how the traceable requirements are properly associated with the design specifications. It's often also called as voice of the customer or quality function deployment. Oftentimes, the voice of the customer has these days been reduced to nothing more than a set of survey questions. But that's not just voice of customer. According to quality, voice of customer includes how the requirements are mapped to the technical specifications and how these are ranked for proper prioritization. So now let's take a look at the example on the right-hand side. The way you start doing this is by first developing a set of customer requirements. We add a numerical score from 1 to 5 for each customer segment. Then we develop a list of technical design elements along the roof. Identify the targets such as the metrics and difficulty in the foundation. Then we demonstrate the relationship between the customer's requirements and technical specifications. Now this crossroad initially could be marked with a X for dependency. Then we perform competitive assessment on the back. Then we move forward with evaluating the priority of technical design elements mapped to the requirements based upon the customer rating and the customer requirements and the technical design elements required to support these requirements. You can now replace the X in the yellow section with appropriate ranking. Finally, towards the top, you can start putting the conflicts that arise from different technical specifications and the mapped requirements. Those that have used the house of quality approaches to mapping the requirements and specification, and then these categories with the test cases have seen benefits in many areas that contribute to poor quality. There is stronger evidence addressing poor product definition, failure to strategically prioritize, and address poor communication. These address some of the Muda and Muri. There is also increasing evidence on addressing technological uncertainty, senior management support, getting resources, and better project management. This leads to the final element of managing project quality. Based on my experience, I would like to share my thoughts on how projects can uphold quality. Quality control activities should begin before development. Testers should write the test cases, and developers will have to code for the tests to pass. These are the basics behind test-driven development. Testers will write scalable test cases. In other words, they should be able to group similar test cases for scenario testing. They should also have parameterized tests that can support increased flexible testing. The tool that you are using should allow parameters. Quality is everyone's responsibility. So collaboration with others, operations, end users in the software delivery will continue to surge. Test case review and approval will become part of the governance workflow as well. Quality process engineering related work will become mainstream. So scalability, stability, and manageability in design will emerge. Additionally, privacy, security, and performance testing will take center stage as part of quality. Finally, automation will increase along with acceptance testing. Developers will frequently build and unit test. Testers will also engage in exploratory testing. This takes us to the demo time. For the demo, I would like to demonstrate the following. First, I would like to make sure that you understand the process of defect triage. So what are the different defect statuses that are available, how you can go about solving them using the workflow. Then I would like to introduce how the test cases are developed and what are the elements of a test case. Then I will introduce the test set, which is going to be grouping of test cases for a specific purpose, and execute a few test runs to see how things work. I will also include what is called parameter to customize the test case and test sets. For the demo part, let's start with the administration session. I am right now in my cloud instance, and underneath the incident section on the administration panel, you will see types, status, priorities, severities, and workflows. And you can categorize defects by different types of defects. So it could be a bug, it could be a change request, enhancement, incident, issue, limitation, risk, or training. So you can customize these things according to your needs. The next one is going to be the status, the state of a particular bug, so that you are able to trace through your workflow. Now we have a set of default options that are listed over here, and how you want to prioritize the bugs. That's also listed over here. All these things can be modified as well. And priority, and similarly you have severity as well. And finally you have the workflow. Now I'm going to go inside the workflow. You have already seen similar workflows before, so I'm going to go inside this workflow. And inside the workflow, you start with new, and then you will have different options that are available here. These are the transition operations, and depending upon that, you can assign the incident. If it's found valid, you can automatically close it. You can consider it as duplicate. You can basically send it back to the tester for more information because you are not able to reproduce it, or have it reviewed by another person as well. So these are all the options that you have available, and all these things can be customized as you need it. And when you look inside the transition option itself, you also have an option to require electronic signature, which we discussed last time. And all those informations are available at this point that you can customize for the defect workflow. Now I'm going to move inside the testing panel. Under the testing panel, you have the test cases. Let me go inside the test cases at this point. So under the test cases, we have a list of test cases that we have created over here. And the first test case I have over here is test case standalone with parameters. So that's my use case 1. So it's going to be standalone. So when you look at that particular one, you have a list of conditions, and you have here information that you have added. It's like, use my operating system and log in to this particular location with this user ID and password. Now if you look here, these are all parameters over here. It uses some kind of a token. Now what would that token be? So when you click on this, because I have only one step, I'm going to click on this here, and you can see that my OS is pretty much listed as my OS, and then password I have given Tiger and user ID as Scott. So this way you can make sure that that information is not listed here, but it's part of the parameter. Okay. This could be automated as well. If you have automation engine configured, you can basically invoke that automation engine, put the test script over here, or if that script already exists in a repository, you can link it or attach it, and all those things can be done over here. And for that particular automation engine, you can pass some additional parameters through this particular option here. So that's this piece. And so let's go through and quickly execute this. So when I execute this, let's see what comes up. So you see this panel over here. In this panel, it basically replaced the values that I had, the Scott and Tiger, as well as my OS, with the actual token. So it replaced the values or the parameters that I had passed with the tokens over here. So it is able to go ahead and implement that. So now let's move forward with the second one, which is going to be, let's go to the test case again. And let's go through this one. So use case, test case with linked test cases. So you saw in the previous one, we basically had a test step. And if you already have a test case that is completely baked, then the test case itself can become a linked test step as part of another test case. So now I have a second use case, but in the second use case, I basically have called the previous test case itself. So use case 1 and use case 1 is listed over here. Now what are the differences? So because there are two steps over here, let me select one of them and then click on the parameter here. So when I click on this one, it basically says Linux, use Linux, and Scott, Linus as the password. Right? And then when you go and look at this one, the second option, it says Linux, Scott, and Linux. So I basically have passed different parameters over here potentially, right? So basically Windows and Linux are the change over here. Now if I go ahead and execute this particular one, let's see how it looks. So in the first one, it says use Linux, and then come here, Scott and Tiger. So what happened to the Linus that I gave? So that one was just a data point that I had provided, but then it was linked. So it went to the link and looked up the Scott and Tiger password and replaced it over here. So it looked very nicely for me, right? So I am able to use the systems over there. And then when you go into the next steps over here, it basically says, Windows, come here, user ID Scott and Tiger. So it's actually able to go and look at the parameters that are the part of the test case itself and substitute that in the tokens. Okay, so let's move forward with the test sets. Now, test sets, you can create a lot of different test cases, but then you can group the test cases for certain specific functionality so that you can reuse them. Now, I have created some test sets over here. So I'm going to go ahead with the use case number 3, which is test set without any test set parameters. So let's take a look at that right now here. So it's almost the same thing as a test case, but when you come down over here, you see the test cases listed. Previously, you had the test steps listed. Instead, you have the actual test cases listed. Now here I have the test case standalone with parameter and test case standalone with parameter. The same thing that I previously had, I have listed them over here. But at the very top, I have something called a parameter over here. Now, the parameter for the test cases that I currently have can be overridden. For instance, if you recall, I had some test case linked and then I actually executed that. Remember that Linux, and it was not picking it up, right? So now I want to be able to override that. If I want to be able to override that, I want to use a parameter at the test set level and pass that. For now, I'm not going to pass anything and see how this is going to look. So I'm going to go forward and execute this test set. So there are two test cases which are pretty much the same, but with some different parameters. So when you execute this test case standalone with parameters, you have the my OS, come here, app1 user and app1 password. Where did that one come from? Now let's move forward to the second one, and here it said Scott and Tiger. So how did this change? So let's take a look at how that has changed over here. So if you come to the use case 3, test set without parameters, test set parameters. Now I want to go ahead and click on this one and look at the parameters. See, I overrode the test case parameter using parameters that are available over here. In the previous case, it did not work. Now I'm able to make it work because I'm overriding the test case parameters with what I want the test case to use. So it's not going to pick up what the test case actually had as parameters, but it's going to override it. Now, because I didn't give anything for my OS, it used whatever the test case had. But because I overrode those with user ID and password with app1 user and app1 password, it actually substituted that information. But in the case of second one, I still had Scott and Tiger. So let's take a look at how that looks here. When you look here, I have everything back. In other words, I'm not passing any parameters, and so it picked up what the actual parameters were for the test case itself. So now you are able to see how I'm able to inherit the test case parameters as well as override it. Now I'm moving forward with the test use case 4, which is going to be the test set with test set parameters. So I'm going to override the test set parameters itself. So here it's pretty much looking like exactly the same one. So let's take a look at this one and edit the parameters, and it says app1 password. Okay, looks exactly like that. And if you look at the second one, I don't know, parameters. So it's exactly like that. But in addition, what I have done over here is at the test set level, I have replaced something. So whenever you see the user ID and you see this app1 user, the Scott, I wanted to change to app1 user over here. Okay, so if you come here and take a look at this, it's app1 user. Okay, so I am replacing at the highest level what the value should be. All right, so let's execute this one. You still see the same different two test cases. So for the first one, it says my OS, login here, user ID, app1 user, app1 password. Looks very normal to me, right? But when you go and look at the second one, use my OS, login, user ID, app1 user, but password became Tiger. You see, the previous one, I had only asked the user ID to be replaced at the test set level, but I didn't ask the actual password to be replaced. So it replaced the user ID, but for the password, it inherited what the test case was, right? So I'm able to use this over here and make the change. Now let's go forward and look at the last one, which is going to be use case 5, test set with parameters and config. In order for me to show what the config is, I want to go and take a look at this one. So previously you saw, I had different OS and browsers and all those things, right? So you had Linux and Windows coming repeatedly. Now that itself I was typing, right? You saw that it has been typed. Now I want to make sure that it's available as a set of configuration. So I basically come and list all these things as a list of configurable parameters. So for my OS, I have 2 different values I have added, and I have made this active. And then I came over to the test set side and associated that configuration with the use case number 5. I just want to make sure that you are able to see that. And now when I come to the test set, use case 5, test set 5, this is the one that we were talking about. When you look at this, it's looking exactly the same, but I'm still overriding the MyOS under test set level password, test set level user ID. So I have basically replaced both Scott and Tiger and MyOS with these information. Now these are the same information like you had before. So app1 password or app1 user, and this one is empty completely. Previously you saw this one was getting replaced as Scott and Tiger. Okay, but now I replace all the information over here. In addition, at the very top, there is something called this configuration, and I have actually picked up that operating system that I had actually shown. This is the only one that's available, and this is the only thing that you saw I had entered. So now if you go ahead and execute this, you see 2 test cases, and you saw 2 different configurable parameters. So the cross product is going to be 4. So you see 4 different things that are coming up over here. So for every configurable option, these test cases are going to be executed. So now the first one is Linux, and user ID is app1 user and app1 password, which we had overwritten perfectly fine. And then let's go forward with the second one. So you still have Linux, but login is, but the user ID is test set level user ID and the password is test set level password. Remember, this is the one that we had absolutely no parameters. So it picked up the Scott and Tiger of the test case. Now I have overridden both user ID and password with a different thing, test set level user ID and test set level password, and it was able to pick it up. Now if you move forward to the next one, it's going to replicate that same thing for the next one, which is the Windows. So Windows user ID is this and password is this, which is coming from the test case. And then it moves forward to the next one, use Windows, and then it's basically saying test set level user ID and test set level password. So you see you have different ways in which you can use parameters with the test cases and the test sets to be able to come up with multiple options on how you can go ahead and test. Now that brings us to the end of this demo, and let's go back to our presentation. Okay, in summary, quality is everyone's responsibility. Quality has to be incorporated from a value generation perspective into project, process, and product components. Use the house of quality as a mechanism to include traceability to requirements and specifications. Understand the cost of quality components and build quality by design. Inspection should be carried out before coding even begins. For our Q&A, if there are any questions related to the course administration, I recommend that you reach out to Ms. Thea at marketing@inflectra.com. If you have any questions about the content, please reach out to me at sriram@inflectra.com. The next steps, please take the post-webinar quiz and also register for the final 5th webinar in the series. Thank you for watching.